Hello and welcome to Tribe Topper. In this video session, you are going to learn about drift velocity. So let's understand what is drift velocity. See, the thing is that the ions or electrons, it's not that they are moving at the speed of light like very, very fast. They rather move at a speed no more than just a few millimeters per second. That is because these electrons, it's a huge number of electrons which travel in 1 second. So they are bound to collide with one another and with the walls of the conductor. So when they collide, they stop, they start again. So every time the speed of the electrons is lowered, and when the speed of the electrons is lowered, obviously the value of the current will also be lowered, because current is what? The rate of flow of electrons, and if the speed of flowing of electrons is smaller, the current will be smaller. So low current means the speed at which the ions or electrons move along the conductor. They also move slowly, that they just, we say, drift along the conductor. This slow speed is known as the drift speed or drift velocity. Now we are going to derive a relation between the drift velocity and the current. Now here we have a conductor whose length is L. So I'll just write the parameters first, all the dimensions of this conductor. So we have L, the length of the conductor. A is the area of cross section of this conductor. Small n is the number of electrons per meter cube, and V is the drift speed of these electrons. Then what is the current that is flowing here in a second? So that will be Q by T. So Q, the charge, is number of electrons times the charge on one electron upon T. Now we have to find out how much is the number of electrons in the entire conductor. So in 1 meter cube, the number of electrons is N as given here. Therefore, in the total volume, that will be area into velocity. That will be N times A times V, because area into velocity gives me the volume that electrons are passing in 1 second. Therefore, the current, that will be when T is 1 second, the number of electrons crossing is NAV. So we get I is equal to NAV times E. So this is the relation between the current and the drift speed. Sometimes you might see this formula in your data booklet to be I is equal to NA QV. Just they replace the electron with a charge Q, so that this is applicable not only just to electrons, but if it is the ions flowing, any charge flowing, the formula would be same. So it's that NA QV. This is the relation of the current with the drift velocity. So that's all in this video session. In the next video session, you are going to learn about potential difference.